limiting reactant, that is the reactant that is going to limit the amount of product produced. That is the reactant that runs out first, and when that reactant runs out, no more product is going to be produced, and that reaction stops. So that's the importance of it and what it is. I'm going to run through the steps here on how to work a limiting reactant problem. First, you need to balance the equation. Next, you must find the limiting reactant. We're going to look at a problem here, and you'll see what I mean by find the limiting reactant. The problems don't necessarily say find the limiting reactant, but I'll give you some clues on how you know to do that. Step 3, pick one given amount and use it to find the amount of product produced. Then, you're going to do another stoichiometry problem. This time, you're going to use the other given amount and use it to find the amount of product produced. And whichever reactant produces the least amount of product is the limiting reactant. And that amount of product is how much is produced. So you have to go with the least. Okay, here's our example. The first thing you need to start with is a balanced equation. So we need to balance this one. I think if I put a 2 here, that does that. I have 500 moles of this and 750 moles of H2. So we're going to take one given amount. The question is how many moles of methanol are produced. All right, now, when we look at this example, I have taught you that we always start with the number given in the problem. Here we have 2 numbers given in the problem. And so you don't know which one to start with. When that happens, you know that you have to do limiting reactant. You have to figure out which one to start with. Okay, 750 moles. Okay. So I'm going to start with the 500 moles of CO. And I'm going to use stoichiometry to go to the moles of methanol. That's CH3OH. So, can I use mole ratio? Yes. Moles of CO to moles of CH3OH, just like we did before. The coefficients here are 1 and 1. If there is no coefficient, it's understood to be 1. Moles of CO cancel, and so I end up with 500 moles of CH3OH. What this tells me is that if I use all 500 moles of CO, I'm going to produce 500 moles of CH3OH. Now I'm going to take the other given amount, which is 750 moles of H2, and I'm going to do the same thing and go to the question mark. So, can I use mole ratio? Yes, because I have moles here. So, moles, H2, and then moles of where the question mark is, CH3OH, and it's 2 because of the coefficient here for hydrogen, and 1 because of the coefficient here for methanol. Moles of H2 cancel out, and I'm left with 375 moles of CH3OH. Okay, at this point, we have the answers and can figure those out. But we are not done, so please do not leave it. My question is, how many moles of methanol are produced? We go with the least. We have 500 moles of methanol in that calculation and 375 moles in this one. We go with the least, so that is how much methanol is produced. And a lot of times I will ask for you to identify the limiting reactant, and that will be necessary for you to do. So, from the one that is the least, it was produced by H2, using up all 750 moles of H2. So, limiting reactant is H2. So, you need to identify that. And again, it's the one that produced the least amount of product. And the least amount of product is the amount produced. All right. Now, a lot of times, we'll have other problems after this. You must, and this is very, very important, you must use the amount of the limiting reactant given in the problem for all further calculations. Most students who have trouble on the test or quiz that I give to assess this topic mess up because they forget this right here. You must start with the amount given in the problem of the limiting reactant because it's the one in control. All right, so a part B to this problem might be how much excess reactant remains. Now, in order to answer this particular question, we need to identify the excess reactant. That's going to be the one that's not the limiting reactant. It's the one we have extra of. Then we're going to calculate how much excess reactant is used. Start with the limiting reactant in dimensional analysis and go to the excess reactant. And then all we have to do is subtract the amount of excess reactant used from the amount given in the problem. Okay, the problem we were working with, CO plus H2 gives you CH3OH, and we balanced it. H2 is my limiting reactant, so that means CO is my excess reactant. It has to be a reactant on this side of the arrow. Now, I had 500 moles of this and 750 moles of H2. So what we're going to do is we're going to start with the limiting reactant. So 750 moles of H2, and you're going to go to the excess reactant. So this is what I want to figure out. How much CO I'm going to use up. So can I use mole ratio? Yes. Moles of H2 to moles of CO. Fill it in with the coefficients, 2 and 1. Moles cancel. And so that's 375 moles of CO. And it's helpful to write the word used. So if I use, and I'm going to because H2 is my limiting reactant, if I use all 750 moles of H2, it's going to react with 375 moles of CO. Now, to figure out how much remains, because that's actually what my question asks, is you have to subtract. When I started this problem, I had 500 moles of CO. So that'll be given in the problem, minus the amount I'm going to use up, 375 moles, and that's going to give me 125 moles of CO remain. All right, and that's how you work with limiting reactants.